So we're going to start here. I know it says number 5. That's fine. So we're going to be doing ICE charts. I fully expect you, like when we have a test, when we have a free response question, that's going to be an equilibrium question, I need to see an ICE chart. If I do not see that work, I'm not going to give you full credit. So I have found that when students do not use the ICE chart, they forget parts. They don't think about the whole reaction working together and which way it's going and things like that. So really helps you to use the ICE chart. So we're going to start with pure HI at a concentration of 0.1 molar. It gives you the Celsius. You don't really need it. So I'm going to start by writing the reaction. Everything is gas, which is nice. We don't have to worry about leaving anything out. And I'm going to do some ICE. So since it says pure HI at 0.1 molar, I'm going to put in 0.1 molar and the others at 0. Okay, so our initial is 0.1, 0, and 0. So which way does this reaction have to go to get to equilibrium? It has to go the right. Wherever there's zeros, the reaction has to go that way. So on the left-hand side, our change is going to be minus 2x. Why is it minus 2x? Because there's a 2 coefficient in front of the HI. On the right side of the equation, we're going to have just plus x and plus x, because those all have a coefficient of 1. Now, it does happen in this question that negative 2x and we have positive 2x. That doesn't have to happen. The x's don't have to balance out because moles are not conserved in reactions, but it just works out that way this time. And then for the E line, you're just going to combine those two lines. So the E line becomes 0.1 minus 2x, x, and x. That's what's going to go into your equilibrium expression. So we know the equilibrium constant is 0.016. We're going to set it up, and I'm going to solve for x so I can go back and find the equilibrium concentrations of the HI, H2, and I2. So we're going to do 0.016 equals x times x over 0.1 minus 2x quantity squared. Wow, that looks fun.
Yep. It is.
How are you going to solve it? Foil, quadratic formula. I actually can see there's an easier way to solve this one. You could, if you combine the top and make it x squared over 0.1 minus 2x squared, it would be a lot easier for you to just take the square root of both sides, and then you kind of get rid of that square. You don't kind of, you do get rid of that square. So, take the square root of both sides. I'm going to get 0.1265 equals x over 0.1 minus 2x. And then you got to get the stuff out of the denominator, and you got to combine terms, and hopefully you end up with, I don't think you're going to make the mistakes on the ICE chart. You're going to make the mistakes on working it out. X is going to be 0.010 molar. But is that the answer?
No.
What does the question ask for? It asks for the equilibrium concentrations of HI. Oh, why did that just stop? Equilibrium concentrations of HI, H2, and I2. So I then need to take that and substitute it back into the equilibrium line. Well, H2 and I2 are going to be the same. They're both equal to x, so they're both going to be 0.010. But HI, how do we find the concentration of HI at equilibrium? We have to substitute that in for x. So we're going to get 0.1 minus 2 times x. And that'll give us 0.080 molar. So make sure once you find x, rarely does the question just say, solve for x. Well, actually, I can't think of any questions that say that. They usually ask for one of the equilibrium concentrations, or like in your homework, they give you that part, you solve it, and you find K. Do you guys have any questions about anything I found on here? Where did anything come from? You guys know how I got here?
See, based on whether or not you're subtracting or adding x, depending on which way we have to be moving, right?
Yes. And in the next problem, it's not so obvious, which is why I put it on there. Yeah. Any other? You guys ready to try part B? All right. So this is going to be the same equation.
Question got recorded.
And the K is still 0.016 from the previous problem. It says a new reaction, we're going to put 0.2 molar each of those in the container, and we want to know the equilibrium concentrations. It doesn't really change what we do. Anytime you're given initial values or starting values, you have to make the ice chart. So this time, we've got 0.2 molar of everything. So Max, what do I do for my change line?
Change would be minus 2x, and then minus x.
You can't put minus for all of
I mean
them.
plus x, sorry, my bad.
How do you know that you should minus from this side, from the left side?
I don't know.
Look at the K and the concentration.
You guys have to, do you remember problem 34 on the homework?
Yep.
What do we have to find? Was it
Q.
Q? Q is like the fake K. We actually need to go and do Q. Some of you guys might be able to do it in your head. Actually take all these values, put them into the expression. I think you can do this in your head, 0.2 times 0.2 divided by 0.2 squared. 1. How does 1 compare to K? 0.016. So if Q is greater than K, that means we have too many products. Which way does the reaction have to shift? Back to the left. So that means on the left side we add, and on the right side we subtract. And you do have to have the same sign for the whole side. Like I couldn't plus x for H2 and minus x for I2. A reaction is going more in one direction. You're going to subtract from one side, add to the other side. So now we know which way to go. So if you don't have 0, if you have 0 somewhere, you have to go in that direction. If you don't have 0, you're going to have to figure out what direction to go in. And then we've got 0.2 plus 2x, 0.2 minus x, 0.2 minus x. This one looks like a lot more fun. I'm going to just put the 0.2 minus x squared on top. You guys see where I'm getting that from? And then 0.2 plus 2x squared on the bottom. We can still take the square root of both sides. I want you guys to try to work it out. Practice your math. Just don't forget once you get x to go back and actually answer the question. The question asks what are the equilibrium concentrations. So I kind of have to go back and say, okay, HI is going to be 0.2 plus 2 times 0.14, which is going to be 0.48. And then the H2 and the I2 are going to be the same. And they're both going to be 0.2 minus 0.14, so 0.2 So make sure you go plug it back in, get those final answers. And again, if you can do the chart and get to the equation and you're just having trouble solving it, it's an algebra problem. You guys have any questions about where anything came from? Make sure when you start solving this, the first thing you really want to do is get that stuff out of the denominator, like multiply that to the other side, and then you want to combine your x's. And then I think you're pretty much good to go. All right, let's go to the next one. So with each sort of page, I'm giving you something like special. They're not all exactly the same. So very similar. We're starting with pure N2O4. It's 0.1 molar. We want to know the equilibrium concentrations. So let's start off with an ice chart. Everything's a gas. So my I is pure N2O4, a concentration of 0.1. And I have no NO2. What's my change on the left? Minus x. What about the right? Plus 2x. And you don't have to have the same amount of x's on each side because it's mole ratios. And then for the equilibrium, we just combine them. How do you know I should subtract from the left?
Because it's 0 on the right.
Because it's 0 on the right. I can't, have negative molarity. That's crazy talk. All right, so then we go to set it up. I got 0.36, 2x squared on top, 0.1 minus x on the bottom. I cannot take the square root of both sides. So what do I need to do? I probably am going to do the quadratic equation. I'm going to show you something else you can do as well. Regardless, you're going to have to get this all so everything's on one side and equal to 0. So you are going to have to sort of multiply this out. 0.036 minus 0.36x equals 4x squared. That's just multiplying the denominator onto the other side. So if I put this all on one side, I can have 4x squared plus 0.36x minus 0.036 equals 0. And I can solve. So there's going to be a couple things. I think some of you guys have, I remember from checking calculators on the test, some of you guys have like the quadratic equation program in your calculator. You can actually just enter A, B, C, and it gives it to you. When you do the quadratic equation, how many answers do you get? You usually get 2 roots. How are you going to know which is the correct answer? The one that's going to, so if you got a negative value as one of your roots, that wouldn't work because that would be a negative molarity. If they're both positive, if one of them is greater than 0.1, I can't have 0.1 minus x being negative value. So like you can kind of rule out roots that way. Another thing you guys can do is use your calculator's solver. So I'm going to show you how to do that. You guys have your calculator? Get those calculators out. You want to press math. And you want to go down to the solver. There we go. Oh, I lost it. All right, you want to go to the solver, but don't press anything once you get there. Once you get to the solver, if you're on a screen that says x equals, you want to arrow up. So it says equation 0 equals. And if you have equation there, clear it. We're going to enter our equation. So I'm going to do 4. I'm going to use this little xt theta n for my x, 4x squared. Plus 0.36x